4.3 is a little bit of theory about forced oscillations and resonance and damping. So 4.3.1, you can basically explain what damping means, which is a loss of energy in an oscillation. So all real life situations have energy loss due to resistive forces. So you can mention the three types of dampings: light damping, heavy damping, and critical damping. So critical damping, you might want to elaborate a little more on how critical damping does not allow even one oscillation to go through. So for example, if something is heavily damped, it will probably undergo a few oscillations before coming to a stop. But in critical damping, you have no oscillations. It will eventually just come down to the equilibrium point. So this kind of damping is used in most real life situations like shock absorbers in cars, for earthquake proofing buildings, in bridges. So you might want to elaborate a few examples there. Then state what is meant by natural frequency of vibration. So all systems have a natural frequency of vibration depending upon the material, depending on the mass and the characteristics of the object. For example, a child on a swing. Okay, so the swing will have a natural frequency depending upon the mass of the child, the length of the swing's rope, etc. And now, if someone has to push that child on the swing, that person will be the driving force, and that driving force will have a certain frequency. Now, if the driving frequency matches the natural frequency of the system, the phenomenon will be called resonance, and the swing will be able to attain its maximum amplitude. So you want to explain what resonance means and how it can be used constructively and how it can be destructive in nature as well. So this portion is pretty much theoretical. You might want to elaborate a little more on, firstly on driving force. On page 14 of your notes, you want to mention these conditions under which the amplitude of the system would depend: the frequency of the driving force, frequency of natural oscillations, amplitude of the driving force. Of course, if that will be higher, the amplitude of the system would also be higher. Phase difference between the driving force and the natural frequency, and also the amount of damping on the system. This last point, amount of damping on the system, relates to 4.3.4, which shows a graph of how the amplitude of a system varies with under different conditions of damping. You can see that under any condition, when the forced oscillation is the same as the natural frequency of the system, the amplitude is the maximum. But of course, the amplitude will be much higher when the system is lightly damped. So you want to explain how what this curve actually signifies. Page 15 is simply giving you a few examples of how resonance is, some of them which I've just talked about, and a few other examples like resonance circuits, quartz crystals, and etc. So that covers 4.3. You may not want to get into too much detail here because basically there's not a lot of calculation involved. All that is in this portion is a lot of theory. Okay, so just basic understanding of concepts. From here on we move on to 4.4, wave characteristics.